3.3 Metallic bonding. Metals are shiny elements made up of atoms that can easily lose up to 3 outer electrons, leaving positive metal ions. For example, sodium Na, 1s2, 2s2, 2p6, 3s1, loses its 1 outer electron. Aluminium, Al, 1s2, 2s2, 2p6, 3s2, 3p1, loses its 3 outer electrons. The atoms in a metal element cannot transfer electrons, as happens in ionic bonding, unless there is a non-metal atom present to receive them. In a metal element, the outer main levels of the atoms merge. The outer electrons are no longer associated with any one particular atom. A simple picture of metallic bonding is that metals consist of a lattice of positive ions existing in a sea of outer electrons. These electrons are delocalized. This means that they are not tied to a particular atom. The positive ions tend to repel one another, and this is balanced by the electrostatic attraction of these positive ions for the negatively charged sea of delocalized electrons. The number of delocalized electrons depends on how many electrons have been lost by each metal atom. The metallic bonding spreads throughout, so metals have giant structures. The delocalized electrons that can move throughout the structure explain why metals are such good conductors of electricity. An electron from the negative terminal of the supply joins the electron sea at one end of a metal wire, while at the same time a different electron leaves the wire at the positive terminal. Metals are also good conductors of heat. They have high thermal conductivities. The sea of electrons is partly responsible for this property, with energy also spread by increasingly vigorous vibrations of the closely packed ions. In general, the strength of any metallic bond depends on the following. 1. The charge of the ion. The greater the charge on the ion, the greater the number of delocalized electrons and the stronger the electrostatic attraction between the positive ions and the electrons. And secondly, the size of the ion. The smaller the ion, the closer the electrons are to the positive nucleus, and the stronger the bond. Metals tend to be strong. The delocalized electrons also explain this. These extend throughout the solid, so there are no individual bonds to break. Metals are malleable. They can be beaten into a shape. And ductile. They can be pulled into thin wires. After a small distortion, each metal ion is still in exactly the same environment as before, so the new shape is retained. Contrast this with the brittleness of ionic compounds in topic 3.1. Metals generally have high melting and boiling points because they have giant structures. There is strong attraction between metal ions and the delocalized sea of electrons. This makes the atoms difficult to separate.